And we're back. It's time to sort it out with Mr. Swartout. Here we have work from elastic graph. So we're looking at springs here. We have a spring that is subjected to a force, and then that changes the length of the spring. So we want to figure out what is the spring constant of that spring, and then we want to know what is the work required to do that. So let's remind ourselves what we know about springs. Here's an expression for Hooke's law. The force is going to be equal to the spring constant times the amount of displacement from equilibrium. So then, in the first part we're asked for the spring constant, so that's K. So rearrange this, and then K would be given by the amount of force needed to displace it by some certain amount. And in other words, that's the slope of this line. So you could pick 2 points on this line, find the y-coordinates and the x-coordinates, and then calculate the slope. May as well just use the 0 and the final points. So I would kind of read this as my force, and then the difference between this and this is my displacement, x. So that'll help you find the spring constant. Then let's think about the work. Now we can think about, the final energy state of this is that the spring is stretched, and then that's storing energy in the spring. So it's going to end up with some spring potential energy final, and didn't have any to start. And the work that is needed to do that, we can put on the other side of the equation. So then it's going to end up with this, 1/2 kx squared. That's just the expression for spring potential energy. So we get this. Then let's combine that with what we did up here. K, let's replace that with F over x. Then you'll notice that we have an x on the bottom and we have x squared on the top. So combining that, we have this. Then one of those x's is going to cancel. And then go ahead and pull that 1/2 to the front, so we get an expression for this. So the work would actually be given by 1/2 F times x in this case. But larger point is that the work done on the spring was the force applied over that displacement, and then that stored energy in the spring. So that's what you need for that one.